Hello, this is Mr. Price, and this is the video on the Year 8 Unit 5 module on constructions. We're going to start this homework off with looking at angles and some basic information about triangles. Okay, now let's start off. Now this may be a little bit familiar with your Year 7 lessons, so this is mostly a bit of a recap. Now, the question here is asking us to estimate the angles between these two lines below. And then we're going to measure to see how accurate our estimate was. Now, the first thing I'm going to do here is I'm just going to help myself out by doing a mini protractor of my own with values that I know. Okay, so I'm going to start here as 0. Then I know this angle here is about a right angle, 90 degrees. This angle here is about 180. And then this angle here is another set of 90, that's 270. So basically I've gone around in 90-degree angles across here. Now, this isn't quite good enough, so we'll just get some more values in here. So I'm going to halve all of my angles in here and put in these values as well. So I know half of 90 is 45. So that angle's there, 45. And we're now going to go up in 45 to help me with my estimating. So 90 plus 45 is 135. 45 plus 180 is 225. And then 45 plus 270 is 315. So I can use these little compass points here just to help me with my estimate. So let's have a look at this one. So I'm going to annotate on here roughly a 90-degree angle, and I can see it's maybe just a bit more than, or sorry, just a bit less than half of 180. So if that's here is 180, this line here, then it's clearly just a bit more than the halfway line. So looking for an answer less than 135 degrees. Okay, so it's a bit closer to the 90-degree angle. So I'm going to estimate that to be about 125-ish. Okay, I think that's a pretty good guess. So that's the answer I'm expecting. Okay, I'm also going to estimate this one. So here, it might help if I rotate it so it's horizontal. It just helps you gauge the value. So I'm going to put on my 90-degree angle. It's about here. So once again, it seems about, it's more than halfway, so it's more than 45. And I'd say it's about halfway between those as well. So I'm going to add on about another 22.5 degrees to 45, because that's half of 45. So I'm going to guess that is about 67 degrees here. Okay, so I'm going to put my estimate here of 67.5 degrees. Very accurate, I know, but I think it's about that number. Okay, and hopefully that makes sense. So I've done it just by cutting the bit into pieces and roughly counting up in the pieces that I know. Okay, now let's go about measuring these. So I'm going to put my page horizontally. I'm going to take my protractor, and I'm going to put the crosshair, so this little hole here, right where the two lines meet. Okay, and I'm going to make sure my 0 line here crosses my line here. I'm going to turn that light off. There we are. That make you help see a bit better. So my 0 line crosses this line, and I've got my point on the angle here. Okay. So now I'm going to start off at 0 and count all the way along until I get to my number, and that looks like 115, I believe. So this one here is 115 degrees. Okay, if you measured this and it was slightly more or less, don't worry, as long as it's about 2 within 115, that looks about right. Okay, this one will measure it exactly the same way. I'm going to put my I'm going to rotate it so it's nice and easy to measure. I'm going to put my crosshair on the line, and there we are. I line up my 0 line, and I'm going to go along, and I measure this to be 69 degrees. So my estimate was pretty good. Okay, and well done if you got within that value as well. Okay, question 2. We're going to draw this angle on this line. So I'm going to put it on the end. So I'm going to put my crosshair at the end of the line, and I'm going to measure around to 47 degrees. So that's 40, 45, 47 is there. I'm going to put a little line. I'm now going to draw a straight line from A to my notch, like so. Okay, and that should be 47 degrees. Okay, let's look at this one. I want to draw the angle DEF of 112 degrees. Now to draw an angle, it goes from D, I then travel to E, and then I travel to a point F, and that forms the angle. So my angle is going to be somewhere around here. So I want to draw it at point E. So I'm going to take my protractor, put the crosshair on here, through my 0 line, and measure around to 112. So starting at 0, there's 90, there's 110, 112 is here. Okay, I'm not reading that scale, I'm reading the outer scale. Okay, I then draw my straight line from E, and I need to label this point F. It doesn't matter how long you make the line, as long as you label a point F somewhere on this line, and that angle there being 112 degrees. If you put the angle somewhere else, DEF is angle D to E to F, or the angle formed by the middle letter E. Okay, section 2. Now, I've got 5 different triangles here. I'm being asked to name them. So triangle ABC is a triangle with those letters as the vertices. I notice ABC all has the same length, 3 centimeters. That is an equilateral triangle. And triangle DEF is a triangle with those letters as the vertices or the corners. Okay, and here I have 4 centimeters and a 20-degree line, but I'm not told any other values. I'm not told they're the same, so that one there is a right-angled triangle. Okay, GHI. Okay, once again, there's no known values to this, so again, but this time it's got no special angles either. This is a scalene triangle. Okay, as all the lengths are different. Okay, so at triangle ABC has 3 equal sides, 3 equal angles. That's an equilateral triangle. DEF has a right angle, but all the sides are different, but so it's a scalene right angle triangle. GHI has nothing special about this at all. There's no same lengths or angles, so this is a scalene triangle. JKL, this one's special. These lines here represent it's the same length. Okay, but it's also a right-angled triangle. So this is a right-angled isosceles triangle. Right-angled isosceles. Like so. And finally, MNO is this triangle here. Nothing special about it. It's scalene. And now finally, it asks me to construct any triangle above. Now, I'm not going to go through every single one of these because the video will run for too long. And there will be future homework specifically on constructing each of these types of triangle. So, for the purpose of this demonstration, we are going to construct triangle EFD. Okay, so to do that, I'm going to draw a 4 centimeter line first. Okay, so I'm going to draw my 4 centimeter line. Okay, I then want a right angle at point E. So if this is point E, and this is point F, I'm going to draw a right angle at this point here. So I'm going to take my protractor and measure a 90-degree angle. Now, I don't know how long to make this line, so I'm going to make it fairly long. Okay, I now need to construct my 20-degree angle. So I'm going to take my protractor and measure a 20-degree angle and make a notch. Okay, and then I'm going to join those lines up like so. And there we are. There's my 4 centimeter line with a right angle and 20 degrees there. Now don't worry, this looks a bit weird. We're going to keep our construction lines in. So keep this wigwam shape in there, and that's one done. You should be able to replicate that for triangle LJK as well. And you could even possibly have a go at triangle GHI. But take your time with this one. There's a special trick you need to do first. Okay? If you've got any questions or queries, don't hesitate to contact me in class. Thank you.